Hello, Yuvanshu. I will be asking you a few questions about your JSHS research paper. Could you please introduce yourself with the title of your research?
Google, my name is Yuvanshu Agarwal, and I'm a junior at the Academy for Math, Science, and Engineering. My research is a virtual assistant application to optimize the usage of water and crop yield.
Interesting. Yuvanshu, what is the problem you are investigating and what is the hypothesis of your study?
Google, according to the UN Food and Agriculture Organization, humans need to grow more food to feed an additional population of some 2.3 billion people by 2050. Agriculture wastes over 1,500 trillion liters of water each year because farmers use more water than necessary to keep their crops healthy. Small farmers around the world in particular struggle to optimize their water and crop yield because they lack inexpensive and easily accessible means to obtain accurate insight into crop needs. Therefore, I formulated the hypothesis: if farmers can have an interactive experience by speaking to a virtual assistant, then an algorithm can determine their crop's specific water requirements based on various factors, including potential evapotranspiration, PET, as well as their crop's growth stage based on the factors that affect the accumulated growing degree days, GDD. I have to ask you a question. What makes my research study novel or innovative?
As I know, the future of smart agriculture and delivering accessible crop insight resides in the implementation of voice technology. Virtual assistants like me could facilitate a conversation with the farmer, like you, while presenting accurate crop insight like your crop's water requirements and growth stage in a more meaningful way. Would you like to see a demo of it in action?
Yes.
Hello, Yuvanshu. I am your personal gardener. How can I help you?
How are my crops doing, Google?
What crop are you referring to? Cotton or corn?
I'm talking about my cotton crops.
What is the date?
The date is July 15th.
Today's date is 0715. PET is 9.39 and PPET is 0.44. So, the water requirements for your cotton crops are 5.22 millimeters. Accumulated GDD is 1008.48. So, your crop's growth stage is first flower.
Thank you, Google. Alright, so let me explain what happened. When I first started talking, a natural language processing platform started to characterize and organize the relevant data, from which parameter values such as the crop type, the field ID, today's date, and the age of the crop were taken as inputs. These inputs were then passed to the Python-coded algorithm for computation. In the first part of the code sends an API request to the Aware API, where inputs such as the crop type, the field ID, which is the latitude and the longitude of the location, today's date, and the date the crop was planted are passed as inputs. This means that the farmer can gather crop insight from anywhere in the world. In the second part of the code, the algorithm uses the data from the Aware API to calculate the PET using the Penman-Monteith model. The model relies on the temperature, the wind speed, the relative humidity, and other factors to calculate the PET. In addition, the algorithm also extracts the maximum, minimum, and base temperatures to calculate the GDD and provide PPET and aggregate weather forecast data. The algorithm in the third part of the code utilizes the PET, PPET, and aggregate weather forecast data to calculate the daily and specific water requirements of the crop. In the fourth part of the code, the algorithm determines the crop's growth stage by cross-referencing the accumulated GDD of the growing season with the corresponding GDD for each crop growth stage. In the fifth part of the code, the algorithm converts the final result, which was the water recommendations and the crop growth stage, into a final speech response for the farmer in multiple languages like English, Hindi, Spanish, and French.
Very cool, Yuvanshu. Now tell me, what are the key results of your study and how are they applicable?
Corn needs the most water during the emergence and rapid growth stages, while cotton needs the most water during the emergence and first square growth stages. This is supported by the algorithm, since the algorithm predicted that the water requirements would be the highest when the growing season starts in May, and when the first few months are the hottest and deplete the most water. Additionally, the algorithm also accurately predicted when the water requirements were 0, indicating that the crop is well saturated and doesn't need water when the PPET is greater than 1 and the weather forecast is rainy. Additionally, the growing season days data for the cotton and corn growth stages predicted by the algorithm were within a 5 to 7% difference of published crop data specifying the timing and duration of each crop growth stage. For instance, for cotton in the open bolly growth stage, the growth stage is within the 150th to 165th day of the growing season, and the algorithm predicted the 165th day. For corn, during the emergence growth stage, the growth stage is between the 65th to 73rd day of the growing season, and the algorithm predicted the 67th day. The results from the Google Test Simulator also further validate that the algorithm was able to provide results in a variety of languages and capture the essential outputs and convert them into the final water recommendation and growth stage in the corresponding language. For future research, I plan to incorporate a wider variety of crops as well as different types of languages in the application. There's also the possibility of integrating the algorithm with IoT, Internet of Things, to create a customizable water scheduling system that provides data from sensors.
Awesome job, Yuvanshu. Good luck at JSHS and make it happen.
Thanks, Google.